Okay, so 3.1 is about position, velocity, and acceleration. Okay, so this first box of information is really, really important. This is probably one of the most important boxes of information in this entire textbook. Okay, so the position function is basically some function that is describing the movements.
There's no note on the back of it, too.
Okay.
Where I was.
Okay. Describing the movement or the location of some object. Okay, so the one that they often refer to is throwing a ball or object into the air. Okay, so if you can imagine the position function of something getting thrown into the air. Okay, so this is going to describe more than just that scenario. Okay, but that's always the one I'll kind of refer back to, so because you can think about that, that's easy to visualize. Okay, so FYI, position function is usually used with a S of t. That is generally how you will see it. I don't know why S, just because. Okay, if we're talking about the position of something in terms of how far it is away, okay, increments are going to become important. Okay, so the t is going to be in terms of time. Okay, so usually seconds. Distance could be possibly feet, it could be meters, whatever, but I'm just going to use feet as a reference for how we label things. So if it asks you, what is the position of the function after 10 seconds? Your answer would be in terms of feet, if it was a foot function. Okay, the velocity is simply the derivative of the position function. Okay, so you derive it. So you could write it as the derivative of the position function is equal to the velocity. Okay, so if position is feet, yes?
Sorry, what's the original, like, S of t? Is the S distance?
Yes. Yes. So how would you label velocity if we're using feet and seconds? Feet per second. So remember, anytime they ask you a velocity question, you need to label your answer as feet per second. Okay. Acceleration is simply the derivative of the velocity function. Okay, so if we derive the velocity, you get acceleration in terms of time. Okay, so, sorry, ignore that. How would you label acceleration with feet and seconds? Feet per second per second. Okay, so you can actually abbreviate that a little bit, feet per second squared. Okay, so acceleration will always be feet per second squared, or whatever units they're using, meters per second.
What's squared? The whole thing?
Just the seconds. Just the seconds. Okay. They will often ask you to find the initial position of a function. Okay, so all you would do, if you're talking about the position, guess which function you're going to use. Position function. Okay, so all you do is you take the position function and you just literally plug 0 into it, and that will give you the initial position. Okay, so they use S sub O to represent initial position. That's a variable that you could see. Initial velocity, guess what function you're going to use for the initial velocity? The velocity. And the time, since it's initial, would just be at time 0. Okay. Speed, you guys understand what speed is? How fast something is going? Okay, so in order to find speed, it is simply the absolute value of your acceleration. Okay, so, or excuse me, of velocity. Thank you, sorry, I said that wrong. Okay, so velocity can be measured in a positive or a negative manner. Okay, so it is simply, the positive will just describe the direction. Okay, so in my example of if I throw a ball up into the air, it's going to have a positive velocity when it's going upward, and it has a negative velocity when it's going downward. Okay? Whereas speed will always be a positive number, so it's simply the absolute value of that. Okay? Well said. Okay, so then the displacement, okay, so that's basically the distance that the object travels between time 1 and time 2. Okay, all you do is you use the position function, and you do the final minus position. Okay, so that's displacement. Okay, and total distance, that one's probably the most complicated. Just because it's possible you're going to use velocity, and if you had a velocity, you could have a negative amount of velocity, but total displacement means the total distance that you travel, so you kind of have to use positive values. Okay, so we'll go over an example with total distance. Okay, so let's do a couple here. Example 1 says find the velocity and the acceleration. So how do you find the velocity of the position function? You derive it. So we're going to derive the s of t, and so the derivative of t cubed plus t is 3t squared plus 1. Perfect. Okay, so that is the velocity. Okay, then it says, what's the acceleration? So how do you find the acceleration? You derive that. So acceleration, of time, is the derivative of the velocity. So what's the derivative of that last one?
6t.
6t. Nice. That's pretty easy. So notice unless they give us a time, an amount of time to plug in, we come up with some kind of a function to represent that. Okay, so this next example gives us something a little bit more specific. Okay, so this is a position of some object that is moving on a horizontal line. So we're thinking left and right line. Okay, so if we go to the right, that's positive. And if we go to the left, that'll be a negative direction. Okay, so first question says, what is the initial position of the object? Okay, so what am I going to do to find initial position?
0.
Into which function? The original position function, exactly. Okay, so we're going to simply plug 0 into our position function. And I hope that that is an easy thing for you to solve or simplify. Did everybody get 24? Okay, and since we're talking about movements of an object, we need to label our units. So this one says we've got feet and seconds. So what is my label for position? Feet, very good. Okay, so it's just an initial start of 24 feet to the right over there somewhere. Okay, question number 3 says, what is the velocity of the object at time 1? Okay, so first thing we need to do is figure out the velocity function. So how are we going to find the velocity function? Derive the position. Okay, so I'm just going to go, the derivative is, so what's the derivative of 16t cubed? 48t squared minus 72t. Okay, good. So there's our derivative. So then at time 1, I'm just going to plug 1 in. So we end up with 48 minus 72. So what's 48 minus 72? Negative 20. Anybody want to use their fancy calculator to figure that out? Oh. You don't know how to turn it on? Uh-oh. It's gonna be it is complicated.
How do you go to the calculator?
Oh, okay.
You can turn it on, but it comes up with random options.
Okay. So what you're gonna do, if I had one in front of me, I would show you. But on the home screen, so if you hit home, that should be the screen that you're looking at. There's like I don't know. There's a menu on the left, and then there's on the right. No, on the left there's calculate and graph. So calculate is the screen you want to go to, and I think you have to push the letter A to get there. So if you push the A, which is one of those green buttons, that takes you into where you can calculate everything. Or click enter as long as your cursor's on it, right? So anybody able to get 48 minus 72 on their calculators? Negative 24. Okay, so because I got a negative answer, what is that telling me about what's happening with this object? What direction is it moving? It's going to the left because of the negative. Okay, at a speed of 25 feet per second, going to the left. Okay, number 24, what is the speed of the object? How do you find speed? It's the absolute value of the velocity. So what's the absolute value of negative 24? 24. So that's just 24 feet per second. Sorry, that line was like really horizontal. Oh, do you? Nice. All right, number 5. Ooh, this is getting fun. Okay, acceleration. So how do I find acceleration? Derive the velocity. So if I derive the velocity, I need the derivative of 48t squared. 48 times 2, 96t minus 72. Everybody good there? And then I plug 1 into that to find it at time 1. So 96 minus 72. I think we're getting like a constant. I feel like there's a echo. Feet per second squared, because acceleration is, that's not a normal thing to happen, just an FYI. That's true. I don't know why. Okay. Now number 6, this is like a giant idea on this question. When is the object at rest? Maybe. We can't necessarily assume that. That's likely. When the velocity is 0. So when he's not moving, we're talking about a velocity, okay, a velocity of 0. Does that make sense? When the object is at rest, it has a velocity of 0. So all I'm going to do is I'm going to take the velocity function and set it equal to 0. All right, this is where I'm going to intro into your calculator. So absolutely you can do this by factoring it. Oops, I pulled up Wabbit. I don't want Wabbit. Sorry, Wabbit. Okay, check this out. So everybody is in this screen. Yeah, okay, so let me show you. This calculator can solve equations. Corbin, I'm sorry, I'm out of calculators. You don't get one. But don't worry, I ordered more. They'll be here next week. There's 2 of you guys that are short. So hopefully you can survive for a few days. Okay, so what you can do is if you hit, so this thing can solve equations, this thing can factor, this thing can derive, integrate, all this calculus stuff. Okay? So if you hit menu, is everybody on the screen, by the way? You have to be in the calculate screen. So hit menu, and when you do that, you're going to choose algebra. Algebra. Okay, look at all these things that it can do. Oh my gosh, it's so amazing. Solve. Okay, so now here's the hard part. Now you type the equation in, so you got to go 0 equals, where did I get it from? From my, what do you mean? Like that I'm plugging in here? It's just the velocity equation set equal to 0. Yeah. 48. So X is a green button at the very bottom. All of your letters are green buttons. So you can actually choose any variable at all.
Wait, so we could type in T?
Yep, you could use T, you could use A, you can use any letter you want. The caret is, it's up by the, it's on the left over by the blue button. Wish I had another one. Oh, I do. Look at you guys, they're just popping up. I got one more, you guys. Corbin, you might be in luck unless, you might have to fight Henry for it though. Who wants it?
Henry, go for it. I'm just watching here.
Why'd you put 2 X's in?
It needs batteries though.
Oh no.
Don't worry, I got lots.
So hard.
2 few arguments?
Okay, no, wait, I'm not done telling you what to do yet. Sorry. So after you type in the equation, you have to tell it which variable.
Just want me to put them in there?
Maybe. It might be faster. I have to update this operating system, so after I get done with this lecture, bring it back up and I'll update it for you. Oh, maybe I must have
Try
put
and
those in
remember.
backwards.
Alright, I'll just.
Or maybe it's broken. See if you can fix it.
Alright.
Maybe that was one I put over there for a reason. Okay, so everybody got the equation in? Don't hit enter yet because it won't solve it. You have to say what variable you're solving for. So you have to do comma and then x, solve for x. So comma is down, it's a gray button, a little tiny gray button down by the enter.
Do we do it outside the fence?
Inside the parentheses.
So just do comma and whatever.
Yep. So if you used a T, you would use a T.
Why are we not?
Isn't that amazing? Don't tell everybody that can do this. All the kids in lower level classes will be upset.
They should be. We're upset.
Did everybody get 0 and 3/2? No? Okay. You wanna?
The second one is the right.
Oh, you're factoring, my dear. You want solve.
Oh, okay.
Algebra, solve.
Okay.
See, it factors too. That's pretty cool. All right, everybody good? Everybody get that answer? All right, so moving on, question number 7. Okay, so number 7 is asking us when is the object moving to the right? Okay, so what do we know about what? Say that again, Henry. When the velocity is positive, that is when the function is moving to the right. So when the velocity is positive. Okay, so what I just found on question number 6, I'm going to use those numbers to figure out when the velocity is going to be positive. Okay, so I'm going to use a number line and do a sign test. Okay, now do realize this is a number line for the time with the velocity and not the position of the function. It's not the left and right of the function thing. Okay. All right. So all I'm going to do is I'm going to test each of the increments. Okay. So if I plug a number, let's go in the middle of those two. So let's start with the middle of 0 and 3/2. Give me a number in the middle of 0 and 3/2. 1. That's a pretty easy one, especially since 1 is the number that we plugged into question number 3. So at time 1, was the velocity positive or negative? It was negative, okay? So it was negative. Okay, now I want to test every increment. Generally, it's going to go every other 90% of the time, but every once in a while you get that bounce in the graph. Okay, so you just still have to test every increment. You always want to do that, or every interval. Okay, so I need a number that's less than 0. -1. So if I plug -1 into my velocity, that would be 48 plus 72. Is 48 plus 72 positive or negative? I think so. I'm going with positive. Okay. Now let's pick a number that's bigger than 3/2. 4. Oh my gosh. Okay, 4. I can't do that in my head. 4 or 2, whatever one. Either one. So plug those in your calculators. Plug 4 or 2, whichever one you want, into the velocity. Do you get a positive or a negative number? What? No, velocity. Velocity.
It's 48.
So positive, right? Okay. So we just said that the object is moving to the right when the velocity is positive. Okay, so what are the two intervals where it is moving to the right? When it's greater than 3/2 and greater than 3/2 and when it's less than 0. Okay, so you could write that in interval notation. I kind of like the inequality notation because we are specifically using t as a variable and it gives us more information.
So you wouldn't include 0.
Nope. You don't have to. On number 8, we are moving to the left, so we can use our same little number line that we just did. Okay, moving to the left would be a negative velocity, so what's my interval for my negative velocity? Between 0 and 3/2. So you could write that as an inequality as 0 is less than time is less than 3/2. So that would be in the middle of those two. Or you could write it in any interval notation, whatever you want to do. Good there? Okay, number 9 asks us when is the velocity 54 feet per second. Okay, so you use our velocity function. We're going to set it equal to 54 exactly. So what was our velocity? It was 48 t squared minus 72t. If you'd like to type that equation into your calculator, which I would totally recommend, go ahead and do that. It should start a new one, right? But after you hit enter, it should start a new one. Yep, so you hit menu, algebra, solve. Not working. Maybe it needs like a mini battery in there. Okay. Then I guess I'll just have to give you one of the new ones.
Oh, that's not nice.
Yeah, did you get yucky decimals?
Well, it gave us some fractions.
Oh, can you hit, oh, so if it gives you a fraction, then what you want to do is hit menu, and then number, and number converts somewhere. There should be like an option to convert to decimal.
So you get negative 0.549.
Negative 0.549.
Or 2.
Anybody else get that?
Yeah.
Good there? Yeah, no kidding, right? Like, I did that. Actually, let me show you mine. This is the Inspire before the Inspire.
Does it still work?
Yeah, it still works. Still does everything that thing does. Just is a little heavier.
Why are you using that?
Why am I not using it? I just don't use it that often. I don't really need it.
This thing's gonna like.
All right. So moving on, we're gonna find the displacement. Okay, so the displacement of the object is just going to be the ending position minus the starting position. Okay, so if I'm saying the word position, what function am I going to be using? Position. So I'm going to take the ending time, which is 2, so I'm going to plug 2 into the position function. Position was way back at the top there. It was 16, here let me use a different color. Yeah, 16 So we're going to plug in 2 cubed minus 36 times 2 squared plus 24, and then subtract time is 0. Now, do I have to write out every term if I'm kind of hitting 2 terms with 0? Because we kind of did initial position already, right? Can I go minus 24? Did I lose anybody on that? Because if I plug 0 in, I just get 24.
Negative 16.
So negative 16. So displacement, what are we talking about? 16 what's? The displacement is in feet. Yes. Okay. What does the negative describe about it? To the left of the initial spot. So 16 units to the left, well, 16 feet to the left of the initial position. Okay, so that's where the new thing lies. All right. Okay, so now, number 11 is slightly more complicated because we're talking about the total distance. Okay, so notice that when I did displacement, I got a negative value. Okay, so what I have to do is I need to get total distances, but I need to have positive amounts of distances. Okay, the total distance traveled. Okay, so what becomes important is those resting points, those 0 and 3/2. Okay, and then also my endpoints. Okay, so what I'm going to do is I'm going to use my position function because we're still talking about the distance that's being traveled. Okay, and figure out the total distance between 0 and 2. Okay, so the first part is the starting spot. Where do I start? 0. Okay, so I'm going to start with my s of 0 and plug that into my distance. So 16, 0 cubed minus 36 times 0 squared plus 24. So what do you get for this value? 24. Okay, so then we're going to say that it had that positive distance all the way until, where did it stop? Where was that place that it was at rest? 3/2, so we got to go all the way to 3/2 and figure out what the distance it traveled between 0 and 3/2 was. So I'm going to plug 3/2 in. Whoops. That was the place where it was at rest. Okay, so I'm going to give you guys a second to figure that out. Yeah. On number 10? So all I did is I did the position of t minus the position of 0. So I plugged, so this part right here, so you know my position function? The original function. I just plugged 2 into it, that's that piece. And then I plugged 0 into the position function. This is me abbreviating, plugging 0 in because I had 0 plus 0 plus 24, which is 20.
How did you know which one? Yeah, but it's negative 80.
You got negative 80 on this number?
Yeah.
Did anybody else get any different numbers than this?
How did you know which one was like put flat? Like, how did you know put 2 in first and 0 in first? Yeah.
I got negative 3.
Negative 3? Okay. Well, yeah, you're used to using it. Yeah. You got negative 16?
I plugged in 16 cubed squared.
It's cubed.
It's cubed.
Oh, maybe it's because this, yeah, there you go.
How did you know how to put
Cubed.
why put 2 in first?
Are we talking about number 10? Because by definition, displacement is the ending position minus the initial, like the first. Because the time, what happens first? Time 0 is first, time 2 would be after that. So you go the second time minus the first time. What happened? So it's the ending minus the beginning.
2 minus
0.
2
2
minus
is
0.
the ending time. Minus
2. Because 2 seconds is the end, and 0 is the
so
start.
whatever number comes last, you put it in.
Right.
Okay.
Okay.
So there's like 7.
Alright, so what is my ending position on my displacement, or my total distance? My last time between 0 and 2. So we're going to go all the way to 2. So now we're going to plug 2 in. Okay, so if you plug 2 in, you should get Did anybody get 8?
Is the 2 squared on the second part?
2 squared, yes. Thank you. Okay, so to get the total distance, what I'm going to do is I'm going to add all positive numbers. Okay, so notice on the 3/2 I got a negative number. Okay, but I need a positive distance because we're talking about the total distance traveled. So I'm going to add 24 plus 3 plus 8 to find total distance. So 35. So 35, what do we want to measure that in? Feet. Okay?
Why did you subtract?
Because you're going the total distance. The 3 is really describing the direction that it's moving, but I want how far I went. So I'm going to use the positive amounts of it. Okay, so what I'm going to do is I'm going to give you one homework problem. I want you to do number 1. Okay, I know we're not finished with this, but we'll finish it on Monday. You have enough information to finish number 1, which is yes and A, B, C, D, E, F, G, yes.
How am I supposed to remember?